I want you to take a look at this and see if you see a difference between this one and the ones you've been working with in summation notation. We start counting at 0, essentially. The sum from n equals 0 to 7 of 2 times 5 to the n. Now, I'll right away, just to make it easier on you, I'll change this to, let's see, I used I in the last one. Let's use k here. So I'll change the index to k. It could be I, k. And it will happen where they will use n. But if they do that, realize it's not the same n as the Sn, the n in the formula for Sn. It's not the same one. Okay. So how many terms are there in this sum? 8. If you start counting at 0, there's one more than usual, right? So there's 8 terms in the sum. So in the Sn formula, what's n equal to? N is going to be the number of terms in the sum. So n is going to equal 8. So there's a little curveball that you have to just be aware of. Okay, does that make sense? All right. So now with that, let's find the sum. The sum formula says Sn is equal to A1 times 1 minus r to the n over 1 minus r. So let the formula be your guide. What does that formula tell you that you need? Just look at the numerator. What's the first thing you see reading from left to right? I see an A1. We need A1. This is by the way, this is a geometric series because AN, which is, or AK, the way I have it written, AK, with respect to the input K, it is an exponential function. Okay. So I know it's a geometric series. So that's not an issue. So I can use this formula to find the sum. And you might say, well, big deal. I could just write out the sum. It's only 8 terms. What if it were 1,000? Would you want to write it out then? No, but this formula would still be almost as easy to use. So that's the value of it. Okay. So what's A1? How do I get A1? And by the way, technically you could call it A0, but then it gets really confusing, right? Since we're starting at 0, so don't do that. A1 stands for the first term, but you get it by plugging in the lower limit on the index of K. What is the lower limit on the index? 0. So that's weird, but you'll get used to it. So that's 2 times 5 to the 0, right? Which is what? What's 5 to the 0 power? 1, so 2 times 1 is 2. A1 is 2. And what else does this formula tell you to find? R. What's R? 5. And notice it's not the same as A1. How did you get that? Are you just a genius? Well, maybe, but you don't have to be a genius to do it, right? You're a mastermind. Okay. It's the base of the exponent, yeah. Yep. So it's 5. Okay, let's plug and chug. So it's S8 that we're finding. And, okay, so plug in A1. That's 2 times 1 minus what? Help me out here. So, it's 1 minus r to the n. So that's 5 to the 8. Okay, then what goes in the denominator? 1 minus 5. There you go. So all I did was plug in this generic formula. Does that make sense? Okay, and then, well, how could I simplify that denominator? Before I plug it in my calculator, what could I do? Yeah, make it -4. And then 2 over -4 is the same as -2. You could put the negative up top if you wanted. It doesn't really matter. So 1 minus 5 to the 8 over -2. So how would you plug this in the calculator? Very carefully.
Negative divided by 2.
Yeah, that'll work. And if you want to, you could also leave the negative in the denominator. That'll work too. So 1 minus 5 to exponent button to the 8th power. You got to arrow out of that exponent, close a parenthesis, and then Divide by, okay, you don't use the minus button for negative, do you? You use the negative button to the left of the enter button. You don't need parentheses around it. It knows it's a negative 2 as opposed to a minus something. What do we get? 195,312. Is that what everybody's getting? Does that make sense that it'd be positive?
Yes.
It better be positive. Look, you're summing positive numbers together.